Welcome to Scrap Pile Projects. We're going to show you how to read a tape measure or rule using both the inch and metric systems. If you are an aspiring trade worker or want to build your own projects, master the art of measuring now. There are two systems used for measuring distance. They can be thought of as two different languages that tell the same story of how far apart 2 points are. Inch-based measurements are found within the U.S. customary or English imperial systems. The other language of measurement more commonly used throughout the world is the metric system. We can convert back and forth between the two systems, but should never mix the two when making or speaking measurements. Let's start with the inch-based systems. When using the customary or imperial system, we determine how many inches make up a length. But often what we are measuring is not an exact number of whole inches, or it might be less than 1 inch altogether. When this happens, we divide the inch into an even number of sections, and then determine how many of those fractions of an inch make up the dimension. We can divide the inch many times to get a more precise measurement. Rulers and tape measures have the inch evenly divided and marked out in graduations. Most measuring errors occur because the user does not understand how the tool is graduated. Let's imagine from here to here is 1 inch and make our own graduated tool. Since the inch is always evenly divided, we will start by dividing the inch in half and putting a graduation mark at the half-inch point. The half-inch mark is the second longest fractional graduation mark on the scale, second to the full inch mark. Now we divide each half-inch section in two, leaving us with an inch that is divided into quarters, with marks at 1/4 of an inch, 1/2, 3/4 of an inch, 4/4 of an inch, or the whole inch. Notice the marks at the quarters are shorter than the half-inch mark. But if we try to measure this thing, we see that it falls between two of our graduation marks, and we cannot say with certainty how long this thing is. We need to divide the inch further. Dividing each of the 1/4 inch sections in half gives us the inch divided into 8 equal parts, each of them being 1/8 of an inch long. Low precision rulers are graduated in eighths of inches. The 1/8 inch graduation marks are shorter than the quarter marks. Now when we try to measure this thing again, we see that it lines up with the 5/8 of an inch mark, and we can say with more certainty that this thing is 5/8 of an inch long. But if we try to measure something else, we see that it falls between two of our graduation marks. We could estimate if tolerances allow, but we can only say with certainty that this is between 1/2 and 5/8 of an inch. When we need precision, we need to use a tool that has the inch divided further. Splitting each of our 1/8 inch sections in half gives us an inch divided into 16 equal parts, or 1/16 of an inch. Now we can measure that something else again, and say with certainty it is 1, 2, 3, 4, 5, 6, 7, 8, 9/16 of an inch in length. You just saw me count out from 0 each of the 1/16 inch marks, but since our graduation marks are different lengths, we don't really need to do that. The half-inch mark is easily found, and since we know that 1/2 is 8/16, we can start here and see that this is 1 more 16th, giving us 9/16. A lot of general purpose tape measures and rulers are graduated and marked out in 1/16 of an inch, and many job site measurements can be made to this level of precision. But when the measurement needs to be more precise, we have to divide further. Splitting each 1/16 inch in half allows us to measure to within a 32nd of an inch. And if that still isn't precise enough, dividing each of those 32nds in half allows us to measure with certainty to within a 64th of an inch. This machinist ruler, part of a machinist square, shows the inch divided into 64ths. We can keep evenly dividing the inch into smaller and smaller sections to get a more precise or exact measurement. But as you see on the 64th inch graduated machinist ruler, the lines get extremely close and the tool becomes tough to use with the human eye. When we need to measure with high levels of precision, we move on from tapes and rulers and use calipers or micrometers that help us measure into the thousandths or 10,000ths of an inch for precision work. Now that we have divided the inch into the common fractional graduations, Let's look at some measuring tools and how they're graduated. This tape measure has marks at each 16th of an inch, while this one is more precise, with each inch divided into 30 seconds. This tape has the first 12 inches divided into 30 seconds, while the remaining inches are only divided into 16ths. It can be common for tools to have areas with different levels of precision, so you must be aware of this to make accurate measurements. This machinist square has a ruler with the 4 commonly used fractional graduations, one on each edge. We can measure to 8ths, 16ths, 30 seconds, or 64ths depending on how precise we need to go. And yes, we could use the 64th scale for all measurements, but if we only need to measure or mark to the 1/8 or the 1/4, it's easier to use the less cluttered scale. Not all inch-based measuring tools are divided fractionally. This less commonly found ruler has fractional measurements on one edge and a decimal scale on the other. The decimal scale has the inch divided into 10ths, 20ths, and 50ths. Decimal measurements are expressed as decimal numbers instead of fractions. For example, this measurement would be 3.7 inches. Decimal rulers are not as common, but they are out there and can be easily mixed up with the typical fractional graduations. So always acknowledge the tool you were using and its level of graduation before you measure. If the graduation is not printed on the tool, you can always count out each mark and see how many times the inch is divided. There are other specialty measuring tools with scales and graduations meant for specific purposes other than typical measurements. This 24-inch long ruler has the typical 16th-inch fractional graduations on one edge, but the other edges have marks that are used for typesetting measurements, not typical dimensional measurements. This specialty tape measure is graduated in 64ths, but designed to only measure diameters. Right away you can see that the inches don't line up with a typical tape measure. This tape is wrapped around the circumference of a round or cylindrical object to measure its diameter. If we try to use this for flat length measurements, we will be way off. We keep saying this because it's very important. You must acknowledge how your measuring tool is graduated and its purpose, and realize you can only measure with certainty to the tool's precision. If the tool is graduated in 16ths of an inch, we are only going to measure with certainty to within a 16th of an inch. When using a 16th inch graduated tool, your fractional measurements are going to have a 16, 8, 4, or 2 in the denominator. Since the inch is always evenly divided, the denominator will always be an even number. You should never end up with thirds or fifths or any other odd number in the denominator when using a typical fractional ruler. When expressing inch-based measurements with a coworker, keep in mind fractions can always be converted to decimal form by dividing the numerator by the denominator. Some tools have the decimal to fraction conversion printed on them for quick reference. The single apostrophe is sometimes used to express feet, while a double apostrophe is used for inches. For example, these all read 7 feet, 2 3/4 inches. When referring to a large number of inches, we group them into bigger units. 12 inches makes a foot, 3 feet makes a yard, 22 yards makes a chain, and so on up to and beyond a mile. Most trade worker measurements are made with feet, inches, and fractions of an inch. Measuring gets easier and faster with practice, so grab a minimum 1/16 graduated tape to get started. Now let's switch to measuring distance with the metric system. Metric measurements start with a base unit. For measuring distance or length, the base unit is the meter. Standardized prefixes combined with the base unit allow us to describe measurements that are smaller or larger than the base unit. The prefix deci means 1/10. So a decimeter is 1/10 of the length of a meter. There are 10 decimeters within a meter. The prefix centi means 1/100th. There are 10 centimeters within a decimeter and 100 centimeters within a meter. This is why the US penny is called a cent. It is 1/100th of the US base for currency, the dollar. 100 cents makes a dollar, just like 100 centimeters makes a meter. Moving further in the smaller direction brings us to the prefix milli, abbreviated with a lowercase m. Milli means 1,000th. A millimeter is 1,000th of a meter. In other words, there are 1,000 millimeters within a meter. There are 10 millimeters within a centimeter and 100 millimeters within a decimeter. Going even smaller and becoming too small for me to cut out of this aluminum flat bar, the prefix micro, abbreviated with a mu, means 1/1,000,000th. A micrometer is 1/1,000,000th of the length of a meter. It takes 1,000 micrometers to equal 1 millimeter. You may see the micro prefix as a lowercase mc when printed from devices that don't have a mu key. Trade workers generally don't use micro for their day-to-day length measurements, but we do use the prefix micro often in electronics, especially when referring to capacitors that are typically rated in microfarads, the farad being the base unit for capacitance. The metric prefixes go on further in the smaller direction with billionths, trillionths, and beyond, all the way to base unit times 10 to the negative 30th power. But the millimeter is usually the smallest graduation you find on a metric tape measure or ruler. Some, like this one, have a small section graduated in half millimeters. Since each millimeter contains 1,000 micrometers, this metric rule allows us to measure to within 500 micrometers, and that is as small as we will find usable graduations on metric rules. Beyond that, we would need to use a metric caliper or metric micrometer. We just saw the common prefixes that describe length measurements smaller than the meter. Let's go to the other side and show prefixes that describe multiples of the base unit. The prefix deca, abbreviated with a lowercase da, means base unit times 10. For length measurements, a decameter is 10 meters and is 32.8084 feet when converted to the customary system. Hecto, abbreviated with a lowercase h, means base unit times 100. So a hectometer would mean 100 meters. A lowercase k prefix means kilo, or 1,000 times the base unit. A kilometer or kilometer equals 1,000 meters, and is used instead of the mile in countries that operate with the metric system. A kilometer is 3,280.84 feet when converted to the inch-based system. Going even bigger brings us to the prefix mega, or 1,000,000 times the base unit. Mega is abbreviated with an uppercase m, since the lowercase m is already used for milli. Since a megameter is 1,000,000 meters, we don't use that term when making job site measurements, but we do hear the prefix mega used with other base units, like electrical resistance measurements, or ohms. A mega ohm is a reading you will see on an ohm meter and means a very high resistance reading of 1,000,000 ohms. The prefix list goes further in each direction, both smaller and bigger than the base unit. In the bigger direction, it currently goes to 10 to the 30th power. For job site and workshop length measurements, we generally get by with meters, centimeters, and millimeters. Deca and deci are not typically used on the job site when talking length. We just say 500 millimeters or 50 centimeters rather than 5 decimeters, although all three of those refer to the same distance. On the other side, hecto is not commonly used with meters either. We usually just say 300 meters rather than 3 hectometers. But like we saw, just because we don't use certain prefixes with meters doesn't mean we don't need to learn them, because they will be used more commonly with other base units. Deci is almost always used when referring to sound level measurements, when we say the term decibel, or 1/10 of a bell. Because the metric prefixes are decadic, based on decimal numbers, conversions can be done between the prefix levels simply by moving the decimal point in the appropriate direction and number of places. This also means we don't need to express meters, centimeters, and millimeters separately when referring to one measurement, like we do with feet and inches and fractions of an inch. Let's make a few metric measurements so you can see how they are done and expressed. This thing is 7 centimeters and 3 millimeters in length. But like we just said, we don't need to say centimeters and millimeters. Since there are 10 millimeters within each centimeter, 3 millimeters is 3/10 of a centimeter. expressed as 0.3 centimeters. So we can simply and correctly say this thing is 7.3 centimeters. We can also express this measurement in millimeters. All we have to do is move the decimal point one place to the right, the same as multiplying by 10, since a centimeter is 10 times the length of a millimeter, giving us the same measurement, 73 millimeters. We can also express this thing's measurement of 73 millimeters in terms of meters by dividing by 1,000 and moving the decimal point 3 places to the left, 0.073 meters. 0.073 meters equals 7.3 centimeters, which equals 73 millimeters. All of these refer to the same measurement, even though each uses a different prefix. We could express this in micrometers, kilometers, or even megameters if we wanted to, but for typical ruler and tape measure measurements, it would be unreasonable to express our measurement with so many zeros. Let's look at another example. Here we see this thing has 1 complete meter, 4 complete centimeters, and 7 millimeters of length. But we don't want to have to say or write 3 numbers with 3 units. We condense this to 1 number with 1 unit. Let's choose to express this measurement in meters. 1 meter is 1 meter. 4 centimeters is 4/100ths of a meter, so 0.04 meters. And 7 millimeters is 7/1000ths of a meter, 0.007 meters. All 3 of those numbers have the same unit, so we add them all up for a measurement of 1.047 meters. To express that as millimeters, move the decimal 3 places to the right, 1,047 millimeters. To change millimeters to centimeters, divide by 10, which moves the decimal point 1 place to the left, 104.7 centimeters. 3 different ways to express the same measurement. With inch-based measurements, we get higher levels of precision by dividing the inch into smaller and smaller sections. In theory, we could infinitely divide for extremely high levels of precision, but we will be there forever making the fractions smaller and smaller. And eventually, with any measurement, we reach a level of tolerance that is acceptable. With the metric system, we get higher levels of precision by going further with decimal places. Each decimal place to the right is a smaller and less significant amount of our total measurement than the place to its left. Eventually, we reach a level of tolerance that is acceptable and there's no reason to go further. Measurements and specs for parts have an engineered level of tolerance, such as the thousandths of a unit. And if, say, the thousandths is the engineered tolerance level, whatever less significant digits exist to the right of this tolerance do not matter. Tape measures and rulers are available that have both the metric and the inch-based graduations. Just make sure you only use one system at a time. Don't intermix inches and meters when making measurements. You can convert between the two. For example, 1 inch equals 25.4 millimeters or 2.54 centimeters, but don't combine them within a measurement, such as saying this piece is 3 inches and 7 millimeters long. Keep the 2 measuring systems separate and convert when needed. Whether or not you are measuring with inches or meters, here's some tape measure tips. The hook end of a good tape measure has a little bit of slop or play to account for the thickness of the hook when making outside or inside measurements. Make sure you allow the hook to pull or push into the tape as appropriate. To avoid the play in the hook end for a bit more precision, you can burn an inch, or in reality any amount of the tape. Just remember to account for what you overhang and subtract it from the numerical reading on the tape. If you drop your tape measure, check the hook because it can bend and make your measurements come out wrong. Always keep in mind measurements are only as good as the person making them or the mark being made with them. Sometimes when marking a measurement, a pencil or marker line is okay. But when high levels of precision are needed, we must use a scribe or a scratch-awl that will leave a more precise mark. When making marks for cutting, we need to account for the thickness of the cutting blade or disc and plan the measurement for either cutting to the line or cutting the line, so the final piece ends up with the correct dimensions. Accurate measuring is a must-have skill for anyone who builds, repairs, or designs. With practice, you can be making reliable measurements and speak both dimensional languages with your fellow scraftsmen and trade workers. Once you master tape and ruler measuring, learn how to use the more precise measuring instruments available for the scrap pile professionals who demand accuracy. If you're prepping yourself for a job in the trades and want to see more examples of measuring, continue on to Scrap Pile Projects Measuring Part 2.